scale. Means being a nanoscale, there you cannot ignore the possibility of defects. Defect occurrence means 100% there is a possibility of occurrence of defect, because it is at very, very uh, lower scale, right? So defect classifications are based on this. Basically, two categories are there: synthesis phase and deposition phase. If you would like to understand the fabrication process, what is happening, the QCS cells are fabricated first, right? And they will then deposited on the silicon substrate. So the synthesis phase is the first phase in which the actual cells are fabricated, and deposition phase is the another or the second phase in which the cells are deposited on the silicon substrate. So there are possibility of defects in synthesis phase and deposition phase. Next, you cannot ignore the clock circuitry. As stated, each cell must have the clock. Okay, and beneath of that silicon substrate, there are silicon wires, nano wires. They will provide a clock signal to each and every cell. So there may be a possibility of defects in the clock circuitry as well. So you cannot ignore this one. So broadly, I can say that the defects are classified like synthesis phase defect, clock circuitry phase defects, and deposition phase defect. So talking about the synthesis phase defect, what happened? This cell is going to manufacture or fabricate, in which actually the quantum dots are going to fabricate. So there may be a possibility of variation in dot size. So this diameter may change, the size of this dot may get changed in the synthesis phase, right? The same thing is happening, cell size and space. Means the spacing between two dots may vary, the size of cell may vary. So ultimately, the synthesis phase defects belongs to the distance between two dots, the distance, or we can say that the diameter of this dot, the variation of diameters in this. So that is means it is very, very hard to understand or hard to analyze. But definitely the effect is such that you will easily get to know that this is happening, and your circuit or device will malfunction, right? So this defects means researcher is not able to, the fact is that researchers are not able to analyze the synthesis phase defects because no as such fabrication processes are available, or fabrication of this QC at commercial level is available. So you can concentrate on being a researcher or faculty member, you can concentrate on the defects in the clock circuitry and deposition phase defects, which are easily analyzed using simulation or using the software which we discussed earlier, right? So talking about the clock circuitry defects, there is no as such literature is available which is talking about the various defects of clock circuit. So here is a good opportunity for research, that what will happen if the clock zones are changing, what will happen if clock phase shifting is more than the required in the clock phase. So this can be analyzed in the clock circuit. Next interesting, deposition phase defect. Once the cell is fabricated, that cell is deposited on the substrate of silicon. So suppose you want to fabricate MB and you already fabricated cells in the synthesis phase, and to form a MB, majority voter, you need to deposit it on silicon substrate. So what will happen? There may be a misalignment, that cell may get displaced from this place. This cell is not going to place in this. This is completely missed out or missing cell. Next, some additional cell is going to fabricated or placed. Okay. So these are deposition phase defects. In misalignment, there may be a lateral displacement or cell may rotate like this. So in pictorial form, I have described like this, that to form a MV, what will happen? That any one cell is misplaced from the cell or from this cell configuration. If that displacement distance is within the range, like radius of effect, definitely this cell will interact with this, and there is no as such effect on this device MV. But that cell is far away from this, means above the radius of effect. Definitely the cell A is not going to interact with this device, right? Or with the device cell. So in this case, there may be a possibility of malfunctioning, or device MV will no longer work as a MV, majority voter. Similarly, there may be a possibility of misalignment, that the cell will misalign, right? So original position was this. This is misaligned, right? Similar way, any of the cell is going to rotate, right? This, during the placement of cell A, suppose the cell placed like this. So that angle of rotation can be calculated, and the effect on the output because of this cell rotation can be analyzed. In this rotation defect, cell is not longer available. You haven't placed cell during the deposition phase. So missing cell is possible. There may be opposite possibility that you have, or there is a possibility of extra cell placement which comes under the additional cells. So these are some deposition phase defects which you can analyze easily using simulation based method, and you need to prove using some um, you have to back by some mathematical or analytical proof, right? Then only that work is considered as a publishable, right? So what you can do, one kink energy is available. So I'm just giving you hint. I'm not going into detail. Using kink energy, you can mathematically prove what what why this is happening, right? So first you can simulate all these defects using QCA designer, and then you can go for the mathematical analysis. Okay, recording has started now. Okay.
Actually,
Hmm.
Vishali ma'am,
Yes,
your
yes, ma'am.
PPT is not visible. Now visible. Okay, okay. Hmm.
So I can say that I have completed first part, which is all about QCA, using which device implementation is possible. Next, I discuss the faults, means defects, which you can analyze simulation using simulation, and you prove them mathematically. So I think as far as faculties are concerned, means it is more interesting for the faculties that what are the research opportunities in this field. So first research opportunity is, you can go for a circuit design. You can propose your optimized circuit, even though people have proposed the circuit up to processor. What you can do, you can propose the same circuits in more optimized way, and even you can propose the encryption decryption algorithms or the circuit for these algorithms as far as this quantum computing and the security is concerned. Next, only one type of clocking scheme is available. People are coming with different types of clocking for the QCA. So you can come up with your own clocking scheme. Next, the defects are stated, available in the literature. But what you can do, you can go for, you can propose the new or novel defect, and but obviously if defect is present, you need to go for testing, whether the defect is occur or not. Testing will prove. Okay, so how to test whether that CMOS testing flow will applicable to this or not. So you can think on this. Last, which is not feasible for us, which is the fabrication, but still some facilities are available. You can go for the fabrication of quantum dots, cell, or even some small device. So these opportunities are open for all of us. Next, regarding the updates, Intel and QTech, recently they have delivered a first industrial manufactured qubit. So this is the recent development. They completely set up the qubit manufacturing. And earlier in 2017, they fabricated the 17 qubit processor. So that was for their purpose only, not for commercialize. But this is the news. Thank you for this. Thank you for your patience, for listening to me. I'm not getting questions, but still open for questions and interaction.
Yes, any question from participant? Jara sir, just you see in chat box.
Yes, yes, yes.
No, ma'am, there are no questions. No questions in the chat box.
Shall I go for the detailed analysis? Yeah, participants are eager to see this analysis, or shall I?
Hello, Vaishali ma'am. I have only one question that
Yes.
our student, if they want to do the project, final year project on this topic, which is very new technology, so
Mhm.
whether any of your student are there whom already you guided or like that, so that in evening time or some student will manage their own time and they can learn through online, or is it is not possible at all through online?
It is possible, madam. Online thing is possible. What we can do, my one of my MTech student, she is working on clock circuitry defects, because very less work is carried out on this clock circuitry. So she is analyzing defects, clock circuitry defects. She's MTech student. So in collaboration with her, and in June, month of June, she is coming to Bangalore for
Okay,
internship at Intel. So collaboration online as well as offline collaboration is always possible in this way.
very nice, really very thankful, because if student will learn, then we will be very happy as a teacher. We this is our moral responsibility that we should give our best to the student. So I think then it will be very good and very helpful. And
Definitely. Oh,
second question is uh, how we can able to correlate this quantum dot with the VLSI.
see, ma'am, CMOS, we all know that CMOS means there is a monopoly of this fabrication lab, this lab vendors, right? Foundries. They are not ready to switch over. So they are finding alternatives to CMOS. So they come up with this we can say that FinFET and all, right? More than more 3D ICs and all. So definitely after 3 nanometer, or definitely after some range or some node, they have to switch over that fab lab. So next generation or next thing is based on quantum only, QCA. And
in
obviously
the same
the
in the same foundry
whole
can we
flow of
do
VLS. Yes, ma'am.
in the same foundry in the same
No,
foundry.
no. Whatever I told na, that last one, Intel, the they fabricated whole thing using the available one.
Okay.
They have maintained the legacy of CMOS.
Okay. Okay.
So if that thing is possible, they come up, means there is a possibility of early possibility of commercialization of this. Otherwise, it will take few more years, since they need to uh, completely change their fab. And whatever you are talking, that whole VLSI thing is possible in this way. So reversible logic, that reversible logic implementation is possible using CMOS as well as QCA. So reversible logic based comparator, adder, whatever the reversible gates, you can implement all these gates using QCA.
And QCA software is not available nowadays online, free
Yes,
of
yes, it
cost.
is available. QCA designer setup is available.
It is
QCA
there.
designer second version, and latest version is
Molecular.
QCA designer.
Molecular.
Yes, ma'am. QCA designer E version is also available.
Oh, okay. So there we can design all the universal gate and all, na? AOI and all.
Yes, yes, yes. So in line with the VLSI, whatever we people are doing in VLSI, like RTL coding, the same coding is possible using Verilog HDLQ. Similar way, synthesis is possible, or device level implementation is possible using this. Similar contexts you can go for testing as well,
Mhm.
test algorithms and all.
I
So
think if anybody will work and they will do the comparison, like here they will do RTL, here RTLQ, what you told. In this way, they will do the comparative comparison for any digital, either combinational or sequential circuit. It will be a very great work, I think.
yes, ma'am. Yes, ma'am. Collaboration is
Mhm.
important.
So
One
anyway,
thing,
this was
one
there in
question,
my, yeah.
it was possible to fabricate the circuit using simulation tool for validation purpose. If hardware facility is not, no, no, it is simulator only. It is device simulator, just like your schematic simulator, like this. So simulation, only simulation is possible. Fabrication is not possible.
So simulation level, if anyone is interested to make the paper on this, then it is very good idea to work and simulate. Okay. So any other question is there? You can unmute and you can ask because it is new topic. So maybe people took time
I
to.
I, I don't know whether they got anything or not, whether it is
Hmm.
useful for them or not. I'm little bit.
No, see why we are doing this type of FDP. If many people who are joining they do not have any research problem. Like today
Yes,
morning, Srinivas sir was giving talk. I got lot of idea to give new PhD student what problem I should give. So like this, if your
yes,
talk
right.
anybody has listened today, they got idea that okay, this is we can do this type of problem statement also we can take. Otherwise, everyone is doing PhD in the same VLSI area, same,
Yes,
and it is
yes.
very tough to participate.
Modifying the circuits only.
That's all. That's all. No new thing. No new thing. So this type of FDP is always interesting, and we should learn new things. Okay, ma'am. So I think now no more question. So
Okay.
I will tell Gerard sir to end the session in formally.
On behalf of the Oxford College of Engineering and all the participants present here, I extend a heartfelt thanks to Dr. Vaishali Dhare for the informative talk. We are grateful for the knowledge and expertise you have shared in this discussion, ma'am. We thank you for the time and effort you have dedicated to share your thoughts with us. Thank you once again. Thank you, ma'am.
Thank you, Oxford University. Thank you, Pritha, ma'am.
Thank you. Thank you.
Okay.
Next time again we'll call you. It was very wonderful talk, and we will try to coordinate with you.
Yes, yes,
Okay.
definitely, sure.
For
Okay,
our student project. We are
sure,
very
sure.
interested. Okay.
No
Okay.
problem.
Thank you. Thank you.
Bye.
feedback link now we are posting only in the chat box. So we are not closing the meeting.
Participants, feedback link is already posted in the chat box.
Jarat sir, after some time you close the meeting so that participant will
They will
fill
see the
the,
feedback link, they'll fill it. Okay, ma'am.
yeah,
Yeah,
little
I'll
after
keep it
some
as it
time.
is. After that, I'll end the
Yeah,
meeting. Okay.
after half an hour we will
Yeah.
close this. So now we
Okay.
are not posting in the group. So all of you kindly fill the this feedback form from the chat box.